Now, there are other types of resolutions when we talk about remote sensing satellite images. One is called spatial resolution. So, as you basically know, in any image, when you talk about, you what kind of resolution you talk about is spatial resolution, basically. Okay. So, you know the pixel size, right? The term pixel size, you know. Any image will have the pixel size. If the pixel size are bigger, then spatial resolution of that satellite is less. Again, let me explain this. So, if you are taking a square of 10 kilometer by 10 kilometer, then you are whatever data is present in the 10 kilometer is a overview. But in the 10 kilometer area, if you are using so many pixels of say 10 meters, then it will actually give a very good picture. So top image on the right, if you are seeing, right, the right side one is having a coarse spatial resolution. What it means is that pixel size are really big. In the mid one, pixel size are comparatively reduced from this one, and in the one which is in black, black and white image, it is a panchromatic image, which means it only has the single band, so it's not showing the color. But the spatial resolution is really good. When we are seeing this image, we can see it's not looking blurry or anything. It is actually giving the detail. So this is how you can see. So this is the high resolution satellite image, the low resolution, and the lowest one, right? We can say coarse resolution satellite image. So that is one property of satellite images, which is a spatial resolution property. Another one is spectral resolution. Now, when we went through electromagnetic spectrum, we saw so many bands were there, right? But it's not necessary that in every sensor all these bands are present. So what happens is that it cannot differentiate much between features when spectral resolution is low. So suppose, see, in infrared band there are three types. One is near infrared, one is mid infrared, and one is infrared. Now say green grass is reflecting near infrared very well. Okay, say some other kind of feature is reflecting mid infrared very well. But what if a sensor is not having this three bands separately and it has one band called infrared? It means it is having all the three frequencies in a single band. It is not having it sliced in three different frequencies. So what will happen that it will not be able to distinguish between green grass and the barren land or the other land, which particularly sensitive towards a specific range of electromagnetic spectrum. So here you can see the example. We can classify them in multispectral and hyperspectral. So multispectral will have, I can say, nearly 20 to 30 bands, while hyperspectral can have bands in 400 to 500 numbers. So whenever we want to do some agricultural related studies, like we want to do the crop distinguishing, where is the wheat, where is the rice, if we want to actually distinguish such minute details from the land, we actually required hyperspectral images, because it has so many spectral wavelengths of sensors which can actually distinguish between crops. Otherwise, multispectral is good for broad kind of analysis, such as just to identify water body and distinguish it from barren land or from the vegetation land and the urban land, right? So this is the importance of spectral resolution in the remote sensing images. Then it is called the temporal resolution. Then what temporal, by the term only you can understand that it is related to time, right? So temporal resolution, why is it important to have such distinguishing? Like there are satellites which revisits the particular location twice a day. There are satellites which revisits the particular location twice in a month. Now if you want to give some weather information, right? If you want to make a website which shows temperature of every day, or of different times in a day, then which satellite will you prefer, right? So this is the question where we have to decide that the temporal resolution of the satellite need to be higher when we want to use it for weather application. When we want to use it for mapping or for analysis or any kind of research study, then it's okay if we are using satellite images with lower temporal resolution, but other specifications which are suitable for your application. So whenever see this informations are really important, because when you want to actually work with remote sensing or with the satellite image, you will get to know that there are so many satellites that you are getting on the internet, so many different kind of data sets that you are going to get on the internet, but you don't know what to use, right? You have suppose the assignment to continuously detect the forest fire, to make the system which continuously detects the area and prompts when forest fire occurs. Then what will you do? If what if your sensor is taking data at the interval of every 10 days, right? Will it be useful to you? No, it will not be. So this kind of informations are actually important when you actually want to start working on remote sensing and start working with satellites, right? Then there is one thing is called radiometric resolution. So reflected data from the earth's surface, or we can say emitted, or any kind of data that sensor captures, is stored in digital numbers. Okay, so this digital numbers are brightness levels. So in the third image, uh, you can see in the upper one, it shows little less variation, but the image which is uh, uh, the second image, which is showing quite a clear picture, because it actually shows higher values, right? Because it has more digital numbers, it has more brightness levels, so that it can show this many brightness levels. Okay, so now when you have one satellite image, or say any remote sensing image data, then first thing that you have to do is to do visual interpretation, right? It's there are a lot of processing, everything matters, but visual interpretation is one of the important aspect of it, and this is how you start. So you see there are different images shown in this. Now first element is shape. Okay, what happens is when I'm using multispectral satellite image and I have to detect vegetation, like I have to identify vegetation feature, as well as agricultural features like farms or any kind of agriculture is present on the land. Then what happens is that it shows both the signatures are same, right? Because both have some kind of greenery. And when I don't have images available of very high resolution, then what I have to do is I have to choose the shape. Okay, mainly if you want to identify farms on the land, it will look square or rectangle, right? But if it's some forest area or some shrub land, right? It will not be in any particular shape. So to identify and to distinguish in a better way, what you have to do is you have to have a knowledge that some particular shape might show some kind of particular feature. When you talk about building, it will be in some common shape. When you talk about swimming pool, if you want to distinguish between natural water bodies and artificial water bodies, what will you do? You will see the shape. Both is having water, so both has the same spectral signatures, but shape of one kind of water body is actually regular. It is round shape or rectangle shape, then you can say that it's artificial one. But water body with irregular shapes are not that are natural ones. Okay, so that's why shape is one element for image interpretation. Then is the size. Now if you have small area, what you have to do is you have to identify buildings which are residential and distinguish it from the buildings which are commercial. So how will you do it? The basic information you have is that commercial building must are large in size. It must be bigger than residentials. If you want to identify towers, how will it be? It will be bigger in size. So that is again one thing, that when you are interpreting any satellite image, if you are not able to distinguish it with the spectral property, then what you have to do, you have to check the shape, you have to check the size. Okay, then there is a tone. When I specifically talk about this property, I specifically give example of vegetation, different kind of vegetation. Say it's a shrubland and a grassland. So shrublands are comparatively dense, right, than the grassland. So what happens is that shrublands will be in little bit of dark tone than the grassland. So when you are having a satellite image which has so much of vegetation, variety of vegetation, shrubland, grassland, forest land, then what you have to identify is tone. Okay, so based on this tone, you can actually distinguish that this is not a grassland but a shrubland. Okay, then site is anyway, it's like you should have the basic information of the ground of which you are using the satellite image, because basic knowledge of site will definitely help you interpreting and classifying the image. Then what is next? It's texture. Okay, so now let's get a little bit in more detail. Is that when we have distinguished between grassland and shrubland using tone and all. Now shrubland is also a little dense, and forest area is also dense. So what will help? So the element that will help is texture. You will find really rough texture when there is area like forest land. Also you will find rough structure when there is a hilly area, right? So this kind of information will help whenever you are classifying the image to use further, right? Then shadow information is there when the elevated features are there, and you are using the optical remote sensing images, then there will be problem of shadows as well. So you will have to distinguish between shadow and water body, because shadows will actually look like a water body, it will give the black spot, right? So if you know this, that shadows are there present in the image, then you will see if there are elevated features on your land, you should look for shadows as well. Okay, then there is an association thing. That is again one kind of site knowledge. If you are having image of forested land, and if you from the interpretation, if you are guessing this, no, this is the this is some swimming pool, then it is not possible, right? So what kind of associations should be there in the area which you are exactly trying to get land information of, is one of the thing. Then there is a pattern. So if you are using some commercial area or core of the city, then you will see some pattern. In particular area you will see these are residential area. In particular when city is really planned, then in residential area, if you are seeing something in middle, then you can easily say this is city, right? Because this is how it is planned. So that is the pattern of that area. So these are the properties which should be used